We're still working on Unit 7 Foldable Triangle Congruence. Today we're going to be looking at the Are They Congruent part of your foldable. So turn to, I guess it's the fourth flat. And it should look like this. We have to figure out which property they use to tell whether each of these are congruent or not. So the first one we're looking at, it is a right triangle. So the first property that you should really see if it works is hypotenuse leg. Just as soon as you see a right triangle, you want to try to use hypotenuse leg. That may not be the one that you are going to use in the end, but it's a good guess and a good starting point. So for hypotenuse leg, you of course have to know that the hypotenuse is congruent. So if you look, it already tells us that the hypotenuse is congruent. Okay, that's what the little one tick mark on each side is. And then you have to know that a leg is congruent. Well, we don't know a whole lot about this bottom part on whether they're congruent or not. It doesn't tell us. There are no tick marks, so we don't know. So it can't be that one. But this leg on each triangle is congruent. Remember that we had learned on the last foldable, well, the foldable before last, about the reflexive property, that if the same side is congruent to itself. So these two triangles are congruent because we know about the hypotenuse and the leg. So it is hypotenuse leg. The next two triangles, what we know to start off with is that each side, the top and the bottom, are congruent. That's what these tick marks mean. This one has one, this one has one. And then it also shows us that these sides of the triangles are also congruent. And that's what it means with this tick mark and this tick mark. Well, that only leaves us with one more side to look at, this one right here. In this triangle, they are also congruent because of, as we said with the previous triangle, the reflexive property. The same side is congruent to itself. So these are also congruent. So since we have one side, another side, and then the third side, this is side, side, side. The next triangle, it is also a right triangle. In order to do hypotenuse leg, they have to have a hypotenuse and a leg in common. So, as you can see right away, we see that one of the legs are in common. It's used the same leg. Now it's just really bad highlighting on my part, sorry. That this leg, it does have it in common. So we know that this leg is the same for both triangles. But when we look at the hypotenuse of each triangle, we don't know if they're congruent or not. There are no tick marks. They don't share that side. So we don't know anything about it. So I'm thinking it probably is not going to be hypotenuse leg. But if you look, it does give us this angle right here. So far we know about an angle, a side, and then if you think about it, they also both share another angle. They are both 90 degrees. So angle, side, and then another angle. So we go from an angle to we have two angles and we know the side in between them. And that is, of course, angle, side, angle. The next triangle that we need to look at, it tells you that this side of this triangle is congruent to this side of that triangle. It also shows you that this angle is congruent to this angle. And if y'all remember from two foldables ago, we know that this angle of this triangle is also congruent to this angle of that triangle. Remember that we know that because of our We called it a bow tie. Anytime that our triangles look like a bow tie, we know that the two angles in between are congruent because they are vertical angles. So we know the blue angles. The next thing that we would go to is another angle. And then the next thing we would go to, this vertical is getting in the way, so I'm going to take it off, is a side. So from this angle, we'd go around to the side. So whenever you go in order, we hit angle, here, angle, angle, side. Same thing with this one, angle, angle, side. So that is, of course, like I just said, angle, angle, side. This next triangle, we know that the top and bottom are congruent by the tick marks. We know that this angle is congruent to this angle. And then as we saw on the other triangles, this side is congruent as well because of the reflexive property. So we have side, and then we go angle, and then we go side. And you just have to look at the way we wrote it. We went from a side, we passed over an angle and hit another side. We went from a side, we passed over an angle and hit another side. So side, angle, side. In this triangle, they give us this angle is congruent to this one, this angle is congruent to the first one. We know that this angle is congruent to this one. And then we also know that this angle is congruent to this one because they are vertical angles. So we have angle, angle, angle. Unfortunately, on the previous page of your Foldable, we learned that angle, angle, angle does not prove congruent. So they are not congruent. So, using the given postulate, tell which pair of corresponding parts should be shown congruent. So we have to prove that these two triangles are congruent by angle, angle, side. We already know that this angle is congruent to this angle. And then we know that this side is congruent to this side on both triangles because of the reflexive property. This one right here. And then, if you remember our Z's. Remember, it was not the previous flat, but the one before that. If you have a Z, then we know that the inner parts of the Z's, the angles, are congruent. So, that is angle. Here, let me take the Z off because that's getting a little confusing. I'll put that highlight part back. So we have the angle, and then we have angle, and then we have our side. So angle, angle, side, and angle, angle, side. So now we know that, we also have to know that angle ABD is congruent to angle BDA. That's our green part. So this is all the green part. We have to know that those two are congruent in order to do angle side. Alright, to prove that they are congruent by hypotenuse leg. Well, we already know that they're right. Remember, we have to know that they are right to use hypotenuse leg. We also know that this leg is congruent to this leg on the other triangle because of the reflexive property. So we already know that the leg part is good. What we need to know is the hypotenuse part. So this part. We need to know that that is congruent to that. So we need to know that LM is congruent to LO in order to prove hypotenuse leg. That's the part that we need to know. Right there. Okay, for our next one, to prove side angle side. We already know that this side is congruent to this side. So that's our first side. We already know that the middle sides of both triangles are congruent by the reflexive property. So that's our other side. What we need to know is the angle in between. The angle in between. So the angle is angle ABD is congruent to angle CBD. That's the part that we need to know to prove it. So that's our red part. Alright, on this next one we have to prove angle side angle. So we know this angle. We know this side. Well, we need to know the next angle. So we need to know that angle EFD is congruent to angle HIG. And that is the yellow. Okay, so we're done with this part of our foldable. I am going to go over some of your packet for you. I believe this is where I saved it. Let's see. Next 7. Okay. Okay, let me zoom this out a little bit. Okay, so proofs. They're everybody's favorite thing. We're going to work through some of these proofs to kind of help you fully understand proofs. So the first thing it says is that YWX and YWZ are right angles. So YWX and YWZ are right angles. And then it gives us this. It says the right angle theorem. So remember, all the right angle theorem says that if it's a right angle, that it's equal to 90 degrees. So we know that this angle and this angle are right angles. Therefore, angle YWX is equal to 90 degrees and angle YWZ is equal to 90 degrees. Next, it says that YW bisects angle XYZ. So remember that whenever we bisect, here I'll use the same color to let you know what proves it. So YW bisects XYZ. So that means that these two angles here are congruent. We know that they are because it's of the it's given. Oh, sorry. My screen has messed up again. There we go. Okay, the next thing we know is, as I just showed above, that angle XYW is congruent to ZYW. And the reason for that is exactly what's written right above it. This is why. Because it bisects. So that is called the definition of an angle bisector. Then it says that W is the midpoint of XZ. So if W is the midpoint of XZ, that means that this would have to be congruent with this one. That's what the tick mark means. And that's exactly what it says next. That XW is congruent to ZW because of this right here. And if I wrote it in yellow, you wouldn't be able to read it. So I'm going to go ahead and change this back to black so that you can read it. And the reason why is because of what it just says right there. W is midpoint. So it is the definition of midpoint. And that's the yellow part. It then goes on to say, I need another color. That's not what it says. That YW is congruent with YW. Well, of course, the same thing is congruent to itself. So it says that this side is congruent to that side. It also says, let's see, another color. That angle X is congruent to angle Z. And the reason why we know that this angle is congruent to that one is because we already know that the other two angles are congruent to each other. So these two are congruent because they're both 90-degree angles. These two are congruent because of 3 and 4. And if you already know that the other two angles are congruent, you can assume that the third angle is congruent. The last thing that it gives you is that XY is congruent to YZ. And that was actually given. XY is congruent to YZ. So if you look at all the different colors, the orange ones say that those sides are congruent. The yellow ones say that those sides are congruent, and the green ones say that those sides are congruent. So we know that all sides are congruent. And then we also found that all angles are also all congruent. So now that we know that, we now can say this, that triangle XYW is congruent to triangle ZYW. And the reason for that, it is called, sorry, remember, I have a concussion. It's called the definition of congruent triangles. If you know that all the parts of the triangles are congruent, then the triangles themselves are also congruent. Okay, I'm going to do this one last proof for you, and then you guys are going to have to finish up the rest of the proof section. Okay, so it says that angle D is congruent to angle D. So let me start my color coding again. Angle A is congruent to angle D. And that is because it's given. Oh wait, no it's not. Oh yes it is. Sorry. I can read, I swear. Okay. And then it says that BCA is congruent to angle DCE. So angle BCA, so this angle right here, and angle DCE is congruent. Oh, I forgot to write that the reason why we know that is because they're congruent on the previous. It's given. Okay, we're on pink. Angle BCA is congruent to angle DCE. And we know that because of, like we said before, if you see this bow tie, anytime you see the bow tie, the two angles of the bow tie are congruent because they are vertical angles. The next thing it talks about is the third angles theorem. So if you remember before, if you know if the other two angles are congruent, then the third one is congruent. Well, this is our third angle right here. So we now know that angle B is congruent to angle E. Okay, it then tells us that AB is congruent to DE. AB is congruent to DE. And AD bisects BE. And BE bisects AD. Oh, let me do those in two different colors. So AD bisects BE. AD bisects BE. So we know that this part is congruent to this part. And technically those should be two tick marks. And then it also says more colors. I ran out of colors. BE bisects DE. So that means that this side is congruent to this one. And we know that because it's given. Now, all that stuff that we just wrote, we have to write that those two sides are congruent to each other. So because of the pink one, we know that AC is congruent to CD. And then with the green one, we know that BC is congruent to CE. That's our definition of an angle bisector. That's exactly what we found just above it. Lastly, it says that the two triangles are now congruent. Now that we know that all sides of both triangles are congruent and all angles of both triangles are congruent, the triangles are congruent because of exactly what we said above. It's the definition of congruent triangles. Okay, I will do one more problem for you, and then you guys will have to do this page all by yourself. So back to this page. This is a real world type of example. It says that JK is congruent to ML. So JK is congruent to ML. You know what, I'm going to redraw this picture. Sometimes you need to because it's very hard to see it on the dark picture of it. J, K, N, M, and L. Okay. So this top one is congruent to this bottom one, those sides. And it is, of course, given. It also says that, and I'm not going to keep this here because it would just get in the way, but JK is parallel to ML. So JK is parallel to ML. And that is also given. That's what it says right here. Then it says that angle JKN is congruent to angle NML. Angle JKN, so this angle right here, is congruent to angle NML, is congruent to this angle right here. Now remember that we had learned a property about that. Anytime that you see the Z, so need another color. Anytime you see this Z, remember when we learned that? It was in our second flap, I believe, of the foldable. Whenever you see the Z, that the two angles on the inside of the Z are congruent, which is what the yellow part is. So I'm going to erase this red because I don't want it to get confusing. But they are congruent. I erased too much. Okay. So, if you remember the Z part, these are now called, with the parallel lines, alternate interior angles. We had learned that a while back. Alternate interior angle theorem. Okay, then it says, we already did green, let's do orange. JL and MK bisect each other. Therefore, JN is congruent to LN. JN is congruent to LN. And then MN is congruent to KN. So MN is congruent to KN. And don't forget that that green is also congruent. These are also congruent. So now we do know that all sides are congruent. We can prove it because of the definition of the angle bisector. So remember, it's right here. That's why we can do it. It then says, what color have I not used? That's not what it says. That K and J is congruent to M and L. So K and J, this one right here, is congruent to M and L. Alright, so if you remember, this is one that we had learned earlier. It may be vertical, but it is still a bow tie. Whenever you see the bow tie, these angles are congruent because they are called vertical angles. This is because of the vertical angles theorem. Alright. Now we've got the third angles theorem. Remember, the third angle theorem says that if you know that the other two angles are congruent, then the third one is congruent. Well, we have the blue angles and we have the yellow angles, so the third angles have got to be congruent. So now that we know which ones they are, we can write them. So angles KJN is congruent to angles MLN. Now that we know that all angles and all sides are congruent for both triangles, we know that triangle JKN is congruent to triangle LMN. And we know that because of the definition of congruent triangles. You now need to finish all of this, and you will have to do it on another sheet of paper. You will not have room to do these proofs. What I will, however, write is how many steps each of the proofs have. So number 1 has 5 steps. Number 2 has 5 steps. Number 3 has 4 steps. Number 4 has 4 steps. Number 5 has 7 steps. Number 6 has 6 steps. Number 7 has 6 steps. Number 8 has 7 steps. Number 9 has 5 steps. Number 10 has 4 steps. And number 11 has 5 steps. So that's all you guys have to do today are these 11 proofs, but yes, they will take time, but that's why it's a block day. Alright, and that concludes today's lesson.